What if you traveled over 1 billion miles through the pitch-black void of space just to take a 5-second swim on an alien world? Picture this. You are standing on the shoreline of a vast, shimmering extraterrestrial sea. It is surrounded by towering dunes. The dark waves crashing against your boots look incredibly inviting. But there is a massive catch. You aren't looking at a tranquil ocean of water. Those gentle waves are liquid methane. Your mission today is to dive headfirst into this toxic abyss. But first, you have to survive the drop. Your destination is Titan, the most majestic and bizarre of Saturn's many moons. It is the most promising world for extraterrestrial life in our cosmic backyard. But getting there is not an easy weekend getaway. Even when Earth and Saturn align, this icy world is still roughly 746 million miles away. You face a grueling 7-year voyage through deep space. You need a mountain of provisions, state-of-the-art radiation shielding, and a flawless life support system. If a single oxygen valve fails, it is game over. If your thermal regulators give out, you will freeze or suffocate in the dark, millions of miles from help. But let's assume you are commanding the absolute best spacecraft humanity can build. You can just sit back, relax in hibernation, and let the ship's autopilot navigate the vast emptiness of the outer solar system. After 7 years in the void, you wake up. The view is a cinematic masterpiece. Seeing Saturn up close is staggering. It is the most spectacular ringed planet in our neighborhood. Recent models reveal something incredible about those iconic rings. They are likely the shattered remains of an ancient icy moon, ripped apart by Saturn's immense gravity. You are staring at a glittering graveyard of ice. But you cannot get distracted by the view. It is time to make your way to your final destination. Titan is a cosmic anomaly. It is massive, significantly larger than our moon, and even outsizes the planet Mercury. Titan is a moon that desperately wants to be a planet. As your ship approaches, the surface is hidden. Titan is the only moon in our solar system shielded by a dense atmosphere. It is the only other place we know covered in liquid lakes, rivers, and massive seas. Before you initiate the landing sequence and drop into the unknown, do me a quick favor. Loving this epic journey? Smash like and comment on which planet or moon next. Coordinates are locked in. Buckle up. Descending onto this alien world takes about 2.5 nerve-wracking hours. As your ship vibrates through the upper atmosphere, you must rely entirely on your instruments. The skies here are an opaque, eerie orange haze. You cannot just land anywhere. The surface is a chaotic mix of jagged ice mountains, vast hydrocarbon deserts, and deep liquid basins. If your telemetry is off by a fraction of a degree, you might plunge straight into a freezing sea of natural gas. You carefully steer the lander toward a solid patch of ground near the northern hemisphere. The landing thrusters kick up a massive cloud of alien dust. The main engine finally cuts out. You have touched down safely. Welcome to Titan. Time to suit up and step outside. The thick atmosphere and orange glow might remind you of Venus. Do not let visuals fool you. Venus is a boiling hellscape. Titan, on the other hand, is uniquely freezing. Yet, despite the extreme cold, it remains one of the most hospitable environments in our solar system. Its gravity is only 14% of Earth's. Because the atmospheric pressure is 50% greater than Earth's sea level, you could theoretically walk around without a pressurized spacesuit. Your body wouldn't immediately boil like it would in the vacuum of space. However, you still absolutely need your heavy-duty suit. Why? Because Titan orbits incredibly far from the sun. It receives only about 1% of the sunlight and warmth we enjoy on Earth. You are stepping out into a bone-chilling -290 degrees Fahrenheit. Stepping off the landing ramp, you wouldn't walk normally. Thanks to the weak gravity, your movements feel like a bouncy, slow-motion glide. You could effortlessly leap 10 feet into the air with almost zero exertion. You feel like a superhero bounding across an alien desert. While you bounce across the landscape, consider the ground beneath your boots. Scientists once believed Titan was just a frozen rock, but new, groundbreaking research has completely rewritten the textbooks. But the crust beneath you is not just solid ice. It is a slushy layer of methane clathrates. You are essentially walking on top of a frozen chemical sponge. This thick sponge traps enormous amounts of natural gas. The surface chemistry here is wild. In this ultra-cold environment, substances act in bizarre ways. You kick a shiny rock, except it is not a rock at all. It is a solid chunk of water ice. At these extreme temperatures, water ice is as hard and dense as solid granite. You look up at the alien sky. The atmosphere here is 95% nitrogen, very similar to Earth's. But that is where the similarities end. The remaining 5% is purely methane gas. You cannot take a single breath out here. If you took your helmet off, the sheer lack of oxygen would knock you unconscious in seconds. You would pass out long before you froze to death. As you hike toward the shoreline of your target, you notice dark, heavy clouds gathering overhead. Astronomers recently used the James Webb Space Telescope to observe these exact cloud formations. They proved that Titan has incredibly active weather patterns, raging dust storms, and seasonal shifts. But the dark clouds hovering over you aren't carrying water. They are packed with liquid methane. Suddenly, a heavy drop hits your visor, then another. It is raining. This rain is nothing like a terrestrial thunderstorm. On Earth, gravity pulls raindrops down at roughly 30 feet per second. Here, weak gravity and a thick atmosphere completely alter the physics. The methane raindrops are massive, almost twice the size of normal rain. They drift downward at a sluggish 5 feet per second, 6 times slower than the rain back home. It is a peaceful, surreal experience. You are walking through a slow-motion shower of liquid natural gas. Eventually, the storm passes, and you reach the edge of Kraken Mare. This is it, the largest liquid body on Titan. It is a massive, dark sea that is actually larger than Earth's Caspian Sea. The surface is eerily calm. It reflects the dim orange light of the hazy sky above. You came all this way to test humanity's newest extravehicular thermal suit. Your objective is simple. Take a 5-second plunge into this methane sea and climb back out. Let's break down the extreme physics. This is not a relaxing beach day. You are diving headfirst into a cosmic freezer. At minus 290 degrees Fahrenheit, regular water is essentially bedrock. But methane and ethane have incredibly low freezing points. Even in this brutal cold, they remain fluid, cooling up into massive planetary lakes. Your heavy-duty spacesuit is packed with aerogel insulation and active heating coils. The good news is that when you jump in, you will not instantly turn into a frozen astronaut popsicle. The suit will protect your core temperature. You take a deep breath, step up to the shoreline, and leap into the dark sea. You hit the liquid with a heavy, slow-motion splash. You expect to float. Your spacesuit is filled with pressurized air, and methane is significantly less dense than water. By all standard physics, you should be bobbing on the surface like a cork. But the moment you hit the liquid, something is wrong. You aren't floating, you are plummeting. You look down through the dark orange fluid and realize the terrifying truth. The lake is fizzing. Recent astrophysics data revealed that Titan's lakes are saturated with dissolved nitrogen gas. When temperatures shift even slightly, Massive columns of nitrogen bubbles erupt from the lake bed. You just jumped right into a massive methane nitrogen bubble plume. Because the liquid is filled with gas, it has virtually zero density. You have absolutely no buoyancy. Panic sets in. You thrash your arms and kick your legs trying to swim up, but the aerated, low-gravity liquid offers zero leverage. You are sinking like a stone into the dark, freezing abyss of Kraken Mare. As you plummet deeper, the pressure increases exponentially. Your suit's active heating coils are pushed beyond their maximum limit, desperately trying to fight off the minus 290-degree cold. At a depth of 100 feet, the extreme thermal stress and the crushing pressure finally take their toll. A terrifying sound echoes inside your helmet. Crack! A microfracture tears across the main seal of your oxygen tank. The freezing temperatures instantly breach the suit's outer integrity. Warning! Pressure drop! Your internal computer screams. But the cold is only the second danger. The intense heat from your internal coils suddenly meets the rushing liquid methane and leaking oxygen. Oxygen, methane, and extreme heat. It is the ultimate chemical trap. Bright, violent sparks erupt inside the layers of your suit. Even submerged in a freezing alien ocean, the chemical reaction triggers an intense, localized flash burn. You feel a stabbing, fiery pain right before the icy liquid rushes in. The brutal cold instantly freezes the fluid in your eyes. It locks up your joints. You cannot move a single muscle. Within moments, the crushing depth and absolute lack of oxygen finish the job. You slowly sink to the absolute bottom of the lake, trapped in a frozen tomb of your own making. In 2028, NASA's nuclear-powered Dragonfly rotorcraft will launch toward Titan. It will fly through these alien skies and search for the chemical building blocks of life. Maybe, as it maps the deep northern lakes using sonar, it will spot your frozen suit resting in the dark abyss. Titan remains one of the most fascinating and dangerous worlds humanity has ever discovered. If you enjoyed this deep space adventure, crush that like button and subscribe for more epic journeys. Stay curious, and I will see you in the next one.